When we're trying to identify our different igneous rocks, we're going to be concerned with two things. Our chemical composition, whether it's felsic, intermediate, mafic, or ultramafic, and its texture. So the texture, again, is going to tell us about the cooling history. Where did it cool off and solidify, and how fast or slow did this happen? And the mineral composition, the chemical composition, we're just going to look at based on whether it's light, dark, intermediate, or green in color. So knowing these two things, the chemical composition and the texture, we can fairly quickly figure out exactly what type of igneous rock we're looking at. And for the rest of this video, we're just going to cover some of the most common igneous rocks. The first igneous rock we're going to cover is called granite. This is a coarse-grained igneous rock. This tells us that it cooled off very slowly deep inside of the earth, where there was enough time for the minerals to grow in size so that we can easily see each mineral. These are felsic, they're light in color, and they're light in weight because they're made up of those salt elements. And granite makes up the majority of the continental crust on our planet. And this is going to become really important in our next chapter. But because granite forms really deep inside of the earth, in order to see it here at the surface, it's generally uplifted during mountain building. Whenever mountains are compressing and squeezing together, those rocks from underneath us are pushed closer to the surface. And our second common igneous rock is called rhyolite. This is also felsic. It's light in color, it's lightweight, made out of those salty elements. But the main difference between rhyolite and granite is the texture. It has the same chemical composition, but very different texture. And that's because rhyolite is fine-grained. This tells us that it's extrusive. It's lava that's exited the earth and cooled down so quickly that the minerals didn't have enough time to grow in size. Our third common igneous rock is called obsidian, and this one's one of my favorites. It's one of those glassy textures, which means that it doesn't actually have any minerals inside of it because it's lacking that crystalline structure. All of this is because it forms instantly. It forms from really hot lava dripping directly into cold water, shocking those atoms into place so that there's no crystalline structure and there's no minerals inside of this rock. And while it's dark in color, if we actually look at the chemical composition, it's actually felsic. It's a weird rock. That's probably why I like it. But our next igneous rock is pumice. And if you've ever gotten a pedicure, you've experienced pumice before. This is a really good example of a siccular igneous rock, the one that has tons of air holes inside of it. Pumice forms on the surface of our planet, where the lava cools down so quickly that the dissolved gases don't have time to escape. So all of those gas bubbles instead turn into small holes inside of this rock. But one of the cool things about pumice is that it has so many air holes inside of it, it actually floats inside of water. And at least to the best of my knowledge, this is the only rock on our planet that can float. But we're also going to look at two intermediate igneous rocks as well. So these both have that intermediate chemical composition where they're both light and dark. The first example shown in the upper image is called andesite. So here it's intermediate because it's a medium gray. It's not entirely light or dark in color. But andesite is one of the most famous rocks for being porphyritic, for having that two stages of cooling, starting off deep and slow inside of the earth with fast, quick cooling at the surface after a volcanic eruption. So we find these a lot around volcanoes. And then our second example of an intermediate crystalline composition is with a rock called diorite, which is here on the bottom. And I like to think of it as the Dalmatian igneous rock because it's intermediate. It's about 50-50 light and dark minerals, but it's also coarse-grained. It's made up entirely of large interlocking minerals telling us that it formed deep and slowly inside of the earth. And then our final two igneous rocks we're going to cover are basalt and gabbro. Both of these are mafic. They're dark in color, they're dense, and they have a lot of iron and magnesium inside of them. So basalt is the fine-grained version. This one cools off very quickly at the surface, and it actually makes up most of the oceanic crust on our planet, which will become important next chapter. But again, it's dark in color, but one of the most important things is that it's very dense due to all of that iron and magnesium. The second mafic igneous rock is called gabbro. This one is still dark in color, it's still very dense because of the iron and magnesium, but it's different because it's coarse-grained. It's made up of large interlocking minerals, which tells us that it formed deeper inside of the earth, very slowly over time. So this gabbro is generally not found on the surface of the earth.